Hello there. Today we are going to be talking about simplifying radicals that are not regular square roots. Now, once again, I have to be upfront. I will be using the factor tree method to simplify anything that does involve a constant term. So if you are unsure of how to do that, then I encourage you to look at the Auducation video about simplifying radicals using the factor tree method. If you are all set with that, then why don't we start talking about these non-square root radicals. Ready? Let's begin. We will start our proceedings off with the cube root of 1600, and we will do so in a way very similar to if it were just the regular square root of 1600. We will take the factor tree and break this down into its prime factorization. 1600 is 16 times 100, 16 is 4 times 4, 100 is 10 times 10. 4 breaks down into 2 times 2, both of those are prime. 2 times 2 again. 10 breaks down into 5 times 2. Both of those are prime. Same thing for the other 10 right here. Now we are going to rewrite our radical in terms of this new prime factorization. So this all equals the cube root of 5 times 5 times 2 times 2 times 2 times 2 times 2 times 2. Now, take a look at our index. That is the number sitting on the little table on the outside. It's a 3. This tells us that instead of looking for pairs, we are going to be looking for triples. I see 2 triples inside of here, and the reason for this is because we are essentially taking the cube root of something that is cubed here. 2 times 2 times 2 is 8. The cube root of 8 is 2. So we'll take one representative from that group of 2, and the other one from that one, put them outside the radical, and the only thing that's left on the inside is 5 times 5. Doing all of our multiplication out will give us 4 times the cube root of 25. And that is our final answer. Alright, let's continue our proceedings with the 7th root of x to the 53rd. Now in situations with variables, we must have a power on the inside that is divisible by the index 7. 53 is not divisible by 7, so we must rewrite the inside of the radical as the product of 2 powers, one of which must be divisible by 7. The closest to 53 is 49, which means our second x must be x to the 4th. Now we can take the 7th root of x to the 49th, right? We do this by dividing 49 by 7. So we'll do that, and we'll put x to the 7th on the outside. We have used up that x to the 49th, which means that on the inside of the radical, we only have x to the 4th left. This is our final answer. Finally, we have the 4th root of 384x to the 11th. Notice how we have a 4th root out here, which means when we break down 384 into its prime factorization, we will be looking for groups of 4. 11 is not divisible by 4, so we will have to rewrite x to the 11th as 2 powers, one of which is divisible by 4. 384 is 3 prime times 128. 128 is 64 times 2, also prime. 64 will be 8 times 8. That was easy, right? And then 8 is 4 times 2, prime. 4 times 2 again. Continuing, this is a long factor tree. We have 2 times 2, both of those are prime, and 2 times 2. Alright, here we go. So, we're going to rewrite our radical as the product of all these prime factors. We have the 4th root of 3 times 2 times 2 times 2 times 2 times 2 times 2 times 2. Can't forget those x's. Closest factor is x to the 8th times x to the 3rd. There we go. Well, notice we have one group of 4. We have 4 2's right there. So we're going to put a representative out there. X to the 8th can be broken down nicely since 8 is divisible by 4, so we'll put that outside as well. We will put one representative from the 2's, cross those out, and then 8 divided by 4, that's 2. Finally, we will have the 4th root, ooh, fancy 4 right there, 3 times 2 times 2 times 2 times x to the 3rd. And when we do all of this multiplication out, we are going to get equals 2x squared times the 4th root of 24 x cubed, and that, ladies and gentlemen, does it for this problem. Whew. Take a deep breath. Well, there you have it. Anytime you go to simplify a radical that contains a constant term, make sure you're looking for the index, that is the number on the outside of the radical, to tell you how many numbers you need in each group in order to simplify. If you have a variable in order to simplify, you must have a power that is divisible by that index. If you don't, you must rewrite your variable as the product of two powers, one of which can be divided by the index. You will then divide that power by the index, and that will be the variable that you put on the outside. If you have any further questions, feel free to watch this video again, and I do wish you good luck, and I will see you next time.